All right, in this lesson, we're going to take a look at naming and writing formulas for not only binary compounds, but compounds that involve polyatomic ions. So if you're given the name, obviously you're going to write the formula. And if you're given the formula, you're going to write the name. So in these, they give us the name, we're going to write the formula. Remember, we've got our 3 rules. All we need to do is follow those 3 rules. The first thing we do is we write the symbol of each element. So I'm going to write Ca for calcium, Cl for chloride. Then I'm going to look at my periodic table and figure out the oxidation numbers. We can use our numbers at the top, but we should be able to figure out as well. Calcium is in group 2, has 2 valence electrons, wants to lose those 2. If it loses 2 electrons, it becomes charged 2+. And the chlorine wants to gain 1 to get to 8, so let's say 1-. So then rule number 2 is crisscross down. Or no, rule number 2 I just did with writing the oxidation numbers. Rule 3, I crisscross down. If I cross the 2 there, I don't cross a 1, remember. And the signs, the positive and negative signs, also go away when you crisscross down. Next one, boron, oxide, boron. Write the symbol. Oxygen, write the symbol. Remember, leave a little bit of space in here for possible subscripts. So I'm going to write that again. Boron, I look up, is a 3+ oxidation number. The oxidation number of oxygen is a 2-. I crisscross both of those down and get B2O3. Next one, when you're given a Roman numeral, don't even look at the chart. That is telling you that this is a 2+. So copper is Cu, and it told me it's a 2+. Nitrogen, or nitride is nitrogen, it's a 3-. I'm going to crisscross and put a 2 there and put a 3 there. And again, those are just looking at your periodic tables. Next couple, we've got potassium sulfide, potassium, sulfur, 1+, 2-, crisscross the 2 only, K2S. Magnesium oxide, magnesium is a 2+, oxygen is a 2-, and now I don't crisscross either one of these because they're the same number. And again, I didn't crisscross this 1 up here in K2S because it's a 1, we don't crisscross once. Again, I see this one, iron, Roman numeral 3, that's telling you that this iron is a 3+. So I write iron, which is Fe, 3+. Iodide is I, and it's a 1-. I crisscross only the 3, do not crisscross the 1. And then again, this is telling you that this is a 2+. So I've got chromium, which is Cr, it's a 2+, and I've got nitrogen, which is, nitrogen, 2+, nitrogen, which is a 3-. I'm going to crisscross the 2, crisscross the 3. So again, all you need to do is follow the 3 steps, write the symbols, write the oxidation numbers, crisscross down, don't crisscross 1s, and you don't crisscross the same numbers. And those are for binary compounds. Now if we're looking at the names of binary compounds, again, we just follow our rules, which is write the name of the first element, name of the second element, and if it's a binary compound, so it's just chlorine, we're going to change that to chloride. So this one here is going to be magnesium chloride. That's all there is to it. You do want to look and see if this element is a transition element, because if it is, then you're going to need a Roman numeral. Magnesium is a group 2, so I do not need a Roman numeral here. And remember, you're never going to put a Roman numeral at the end of the second one. Next one, sodium, is in group 1, so it's not a transition element. So I just write sodium, and then I change sulfur to sulfide. Now I get iron. I look at iron. Iron is a transition metal. Iron is in group 8. So this is a little trickier. I do have iron, but I need to put in here what iron it is. And it's iron something oxide. I need leave some room in there. I need to figure out what it is. So how do I do that? Well, I look here and I see there's nothing there and there's no subscript there. There's only 2 ways I have no subscripts down there. Okay? Either the same number or they're 1. Well, if there's nothing here, then these 2 things have to be equal. Either 1s or the same number. So then what I do is, if those two are equal, then these two things have to be equal. And what I'm really trying to find is this one right here. So oxygen, I can look up, is a 2 minus. So the only way this 2 did not cross down there is if this is a 2 plus. So that tells me it's iron Roman numeral 2. This next example is also iron something oxide, but it's different. Because now I look and I have numbers here. That means they crisscross. That came from up there. That means that came from up there. So in this case, it's iron Roman numeral 3 oxide. So again, you look at the subscripts to see what's going on, and then you uncrisscross to figure out what the superscripts are, because the superscripts are what end up going into there. Next one, we've got boron, and it is in group 13, so it's not a transition, so it's just boron and sulfur changes to sulfide. And then we have sodium, which is group 1, so we don't have the Roman numeral there, and that's fluoride. Oops, that's spelled wrong. Fluoride. So again, we want to look always to see what group it's in. Group 1, group 13, but if it's in group 3 through 12, like iron is, transition metal, then I'm going to need that Roman numeral in there. All right, now we're looking at ones that have polyatomic ions, and all we have is one tweak to it in each case. So here, obviously we're given the names, we're going to write the formulas. So I'm going to write this again, remember, tells me that this is lead 4 plus. So I'm going to write PB. Phosphate, the key is this ending. When you see that ATE ending, that's telling you it's not phosphorus. If it was phosphorus, it would be phosphide. So again, the difference is the ending of IDE and ATE. So when you see that ATE ending, that's telling you it's a polyatomic ion. So you're going to have to look up what that is. And phosphate is PO4, and it's a 3 minus. This told me it's a 4 plus. So then I'm going to crisscross. This 3 is going to go down here. Now, if I just put cross the 4, it looks like I have 44 oxygen. Obviously, that's not right. So what I need to do then is I need parentheses around this whole thing and show there's 4 of them, just like you have to do in math. If I look at this one over here, again, this is telling me that this copper is a 2 plus. Carbonate, again, this ending is telling me it's a polyatomic ion. That's CO3, and that's a 2 minus. They're both 2s. I don't crisscross. Since I don't crisscross, I do not need to show parentheses because there's only one of them. I'm not putting a number here. I'm not putting a 2. I'm not putting a 3. So I don't need parentheses there. It just ends up being CuCO3. No parentheses needed. Ammonium. This is not an element. This is a polyatomic ion. Ammonium is NH4, and it's a 1 plus charge. And then again, I've got this ATE ending, so I know it's a polyatomic ion, SO4. And leave a little room here again in case you need parentheses with something. And SO4 is a 2 minus. So here I'm going to cross the 2. Again, I can't just put a 2 there. It looks like I have 42 hydrogens. What I do is I put parentheses around that to show that there are 2 NH4s. There's 2 NH4s in there when I put parentheses with that 2. Cesium nitrate, again, I've got that ending. So cesium is CS, it's a 1 plus. Nitrate is NO3. You'd have to look at your notes for that, and that's a 1 minus. I'm not going to crisscross ones, and I'm not going to have parentheses. Calcium acetate, again, this ATE ending means it's one of our polyatomic ions. Acetate is C2H3O2. It's a 1 minus. Calcium is a 2 plus, so I'm going to need parentheses around that and show that there are 2 of them. Remember, you need parentheses only if there's more than one. I did not need parentheses here because there's only 1 sulfate, but here I do need parentheses because I need to show that there are 2 when I crisscross. Aluminum hydroxide. Now, this is kind of weird when hydroxide does end in IDE, but it's not hydrogen. Okay, hydroxide is OH. So I've got Al and I've got OH. This is a 3 plus. This is a 1 minus. I don't cross the 1. This is a tricky one because you're thinking, well, why do I need parentheses? I can just put a 3 there. It's not like I have 23 or 33. I just have 3. But what this shows, if you do it this way, is it shows that there's 3 hydrogens, but there's only 1 oxygen. And that's not what we have. This is this is a polyatomic ion grouped together. So I need parentheses around that still to show there's 3 of them. Continuing here, we've got this ATE ending. So now I'm going to write, if I'm given names, I'm writing formulas. Calcium is a 2 plus. Phosphate is PO4, 3 minus. I'm going to crisscross the 3, parentheses, and crisscross the 2. Lithium acetate C2H3O2, 1 plus, 1 minus. I don't need to crisscross, and I don't need parentheses because there's only 1 of them. Let's see, there's a 2 here. This again, Roman numeral is telling you that this is a 3 plus. So I've got nickel, 3 plus. Hydroxide is OH. Need parentheses there. That's a 1 minus, parentheses to crisscross the 3. Now, if I'm given a formula, I'm going to write the name. So this is rubidium, and I need to look to see if that's a transition element or not. And rubidium is, where's rubidium? There it is. It's in group 1, so it's not a transition. It's a 1 plus. Chlorate is a 1 minus, so I'm not going to crisscross at all. And I'm going to have RbClO3. Okay, with this one here, this is NH4 is ammonium. And S is sulfur, but it's sulfide when it combines. And I don't need a Roman numeral in here because ammonium is not a transition element. Again, this one here just shows the difference between S, which is sulfide, and SO4, because this one is ammonium, but this is sulfate in this case, because SO4 is sulfate, where just S is sulfide. All right, we've done enough names. Let's just skip down here, and we've done the formulas. Let's just look at these names here. Here we have calcium, and N is just nitride. Remember, if it was NO3, it'd be nitrate. This one here is so. Let's change this. Let's make this. Let's go with one that has a is a transition element. Let's go with iron. Let's go. I got to write the formula part. Let's go with Fe2O3. Okay, so this is going to be iron something oxide. Again, I look and I've got one here, I've got one here, so they crisscrossed. So that's going to be, if I uncrisscross this to get that, it's going to be iron 3 oxide. And then this last one here, we've got boron and nitride. Okay, so again, just follow your rules. It's pretty basic if you follow your rules, and follow those rules until you don't need to anymore, and you should get plenty of practice.